Okay, so today is lesson 1.3 that you've already seen, and we're working on prime factorization. Our learning goals listed all over the place. It's going to be in your workbook. It's up here. It's on your notes. It's on the board. Our learning goal today is I will write a number as a product of prime factors and represent the product using exponents. Once again, do we really understand all that vocabulary? Probably not. So, if you want to write in your notes that I haven't given you, and those out in a second. Actually, I'll do it right now. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. 1, 2, 3, 4. So there you go. There's your notes. But if we look at what that wants to be, and you want to write at the top, just so you understand what we're working on today, is mainly I'm going to give you the number like 20. And what you're going to have to do with 20 is you have to take this number and write it as a product of prime factors. To do that, today you have to show me that you know how to go 4 times 5. That's a prime number. 4 becomes 2 times 2. That's a prime number. That's a prime number. So 2 times 2 times 5. Or 2 squared times 5. You're going to learn how to do that. I'm going to give you any number. You're going to break the number down into prime numbers that are being multiplied. That's what it means by prime factors. Remember, factors are numbers multiplied together to give you a product. Okay? Now, to make sure we can do this today, there's lots in today's lesson. It's kind of tricky. There's 4 things that we're going to be checking on. 1, how do I find the factor pairs of numbers? I'll discuss that with you. Explain the meaning of prime and composite. Create a factor tree to find the prime factors. That's what's in red. That's a factor tree. And then write the prime factorization of numbers. That's what we did in blue. Yes, sir.
When we really doing the breaking it down and making it looking at it, will we be solving that too, or is it just like we can't create it?
What do you mean breaking it down?
Like when you did your factor tree.
Yeah.
And then you got 2 times 2 times 5. Will we be solving those, or is it just?
No, because if I did 2 times 2 times 5, that will give me 20. So that's a good question. There is one part where we're going to look at this to do something else, and I don't really like that. Yes, it has to do with prime factorization, but I think it's another concept tonight. I just don't want us to get lost, but we'll see where we'll be at. So first thing we want to do is we want to do our exploration. I want you guys really to work together right now. So I need you to put your notes to the side because I'm not teaching right now. Oh, that sounds awesome. I'm not going to teach right now. I'm going to go take a nap. For anyone listening to the recording, I am not going to take a nap. I'm going to supervise. My principal's going to be like, I heard you say you're going to take a nap. And now she's going to hear me say she talks like that. I'm going to get in trouble. Okay. If you would open up to 1.3 for me, please. In your workbook, 1.3. Now, on 1.3, of course, at the top, they have what lesson and our goals and our criteria. But here's where you are going to work with a partner. And remember, your partner is everyone at your table group. I really want to see discussion. I want to see you talking. I want to see you moving around. Because I don't know if you know how to do this yet, but together I want to see if you can find the answer. So, it says, 2 students use factor trees. These are factor trees. To write 108 as a product of factors shown below. I will explain what they did, and that's all I'm going to give you. The first student said 108, they broke it into 2 times 54, and then they broke 54 into 2 times 27. So 108 is 2 times 2 times 27. They found 3 factors. Remember, factors are just numbers that are being multiplied together. So they said, oh, I can make 108 3 factors. 2 times 2 times 27. And if you end up using a calculator, 2 times 2 times 27, yeah, it equals 108. Student B was like, shh, I can do it in 4 factors. And so they said, I'm going to say 3 times 36. 3 times 36 is 108. Then they took 36 and said 3 times 12, because that is 36. And then they took 12 and made it 2 times 6. And said, ha! I have 3 times 3 times 2 times 6. 4 factors. What I want you to do is part A. Without using 1, you may not use the number 1, because then you can be like, oh, I did it 57. I did 2 times 2 times 27, times 1 times 1 times 1 times 1 times 1 times 1 times 1. No, can't use 1. Can you make 108 as a product with more than 4 factors? So I want you, if you want to build off what they did, you can, or you can come up with your complete own. But when you list more than 4 factors, whatever your last numbers are, when I multiply them, they have to equal 108. Okay? First table group to find at least 5 factors for an answer wins. Ready, begin. Alright, we're back together. So, 108, pay attention, and then maybe you guys will give me something different. First group. Alright, Miss Quick, what did you guys do with 108? How did you break it up?
We divided it by 4 and got 27.
Okay, so you did 4 times 27 first? Okay.
And then we divide 4 by 2, so we got 2 times 2.
So we broke 4 into 2 times 2. Now, can you break these up anymore? Why not? What is a prime number? Good. A prime number can only be multiplied by 1 itself. I've written up the board. I'm going to make a poster and hang it in the room. I think that'd be helpful. These are prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and the list can go on. But these are numbers that the only factors are 1 in itself. So, a little hint, when I get it to a prime number, I draw a box around it to show that I am done with that number. Alright, just quick, we're going to begin again. 27, how am I going to break it down?
We divided it by 3 and got 3 times 9.
Either one of those prime?
Yes.
3 is. Okay. What about 9?
We divided it by 3 and got 3 times 2.
And is either one of those prime? Okay, what about these numbers? 4, 27, 9, 108. We were able to break them down to other multiplication problems. So because they have other factors besides 1 in themselves, they are not prime, they are what? Very good. Composite. So, prime has only 2 factors. And in parentheses, I'll say 1 and itself. If it is a composite number, I'm going to say 2 plus. Could it have 3? Yeah, if a number is by itself. Number 9 is a composite number, and its factors are 1, 9, And then 3 times 3. Also, it's 1, 3, and 9. 2 plus factors. Awesome. Okay. So, when I would take your 108, and I want to write out what your multiplication is, 2 times 2 times 3 times 3 times 3. We want to take our prime numbers when we're done and write them in order from smallest to greatest. That is the correct answer. She did it with 5. Huge hint. The most you could get is 5. Now, can I write this any other way? Because I'm a mathematician, right? I could be lazy in some areas. I don't like writing 2 times 2 times 3 times 3 times 3. Can I shorten this anyway? Can I be lazy? Ooh, a couple people think I can. How can I be lazy, Ainsley?
You could do 4 times. You could do 3 times 3 times 3 and make it 27.
Ooh, but if I make it 27, that's not a prime number anymore. I have to write in a prime number. You're right, I could, but then I would just write it as 108. I have to write in a prime number. Gio?
You can make the 2 square.
Oh yeah, we did that day 1, didn't we? 2 times 2. 2's being repeated, so it's my base number. And my exponent is 2. I had 2 2's. What would I do with the 3's then, Gio?
Then you would do 3 to the power of 3.
Yeah, and this one just coincidental that the base and the exponent were the same. It's not always going to turn out that way. You know what you guys just did? You did math. Yes. We just really did today's assignment for the most part. You made a factor tree. All those numbers that you came up with were factors. We've identified the primes and the composites. We took those prime numbers and we made them into a prime factorization where they're written as prime pairs with exponents. You did a lot of today's assignment. There's just 1 to 2 other parts we have to do. Now, I'm going to ask you a quick question. Did everyone break theirs into 4 times 27?
I did.
You did. Did anyone not? Wait a minute. Did you get it all the way down? Did you break it down? Did you finish?
Mm-hmm.
Did you get the same thing? 2 times 2 times 3?
Yeah.
You didn't have the same way?
No.
I don't believe you.
You should.
I don't think so. I wish you weren't such a liar to me. Fine. Why don't you just tell me what you did and we'll see.
Okay.
I don't believe you. You have to prove it to me.
Okay. So you break it down into 2 times 54.
Okay, 2 times 54 is 108, and 2 is a prime number.
And then you break 54 into 2 times 27.
Okay, 2 times 27.
Then
2 is a prime number.
And you break 27 into 3 times 9.
Okay, 3 times 9. 3 is a prime number.
And you break 9 into 3 times 3.
Okay, so you had 2 times 2 times 3 times 3 times 3, which, oops, huh, she proved me wrong. Is that the only 2? So there's 2 ways to get it, right? Only. What do you think you're raising your hand for? There's not. Okay, what do you think?
Well, I don't think it's like, I don't think it's gonna be like the same.
Did you have it done a different way?
I know it.
Oh, so this is what I like. You actually didn't do it another way, but you're already questioning me, and you think there might be another way. She's gonna be a liar, just like straight up in front of everybody. I like that because you're thinking. There is another way. Ainsley, did you do it another way?
Yeah.
What do you have?
So I wrote 108 to 3 times 36. and then 36 into 3 times 12. And then 12 into 2 times 6. And then 6 into 3 times 2.
That's I did 2 times 3. If we look at it, she'd have 2 of them. 3, 1, 2, 3.
That's 2.
I'll just make sure you were paying attention. Feeling that life. You have to go when my mom tells me I'm cool. Okay. Now, here's the cool thing. And this is why I like this, and this is why it confuses some people, is that some people don't like that there's not just one way to do it, but a lot of people love it because you can play off your strengths and your weaknesses. If you're really good with multiplication, division, prime factorizations, I love them. I think they're fun. Especially when I give you guys puzzles where you have to find blanks where I put them in. But some people, when I do them, I like them because I think ahead. I don't use really small numbers. I look for perfect squares because a perfect square would be broken into maybe 2 prime numbers. But I can break it in a lot of ways. If I'm not good, I'm going to use my calculator for help. And I'm simply going to do it this way. I'm going to go, okay, 108. Okay, I'm not good with division or multiplication, but it's even. So 108 divided by 2. Okay, that's 54. 2 and 54. There's my prime number. Okay, 54 divided by 2. Okay, that's 27. Yeah. Okay, that's prime. 27 divided by 2. Oh, it doesn't work. 27 divided by 3. Ooh, that's 9. 3 is prime. 9 divided by 2. Doesn't work. 9 divided by 3. 3. Ooh, and 3 is prime. I still get the answer. It works awesome. So, you can use your strengths or your weaknesses on this. The cool thing is, I love how you guys just had this discussion because you already answered B and C for me right now on the backside of this workbook page. If you turn your page over to the backside, we might do this again. We might do B for 80, but you guys really answered C. Is there more than one way to get to this? And one thing I love is like how we didn't just accept what I was saying. Even though you didn't have another answer down yet, she was like, well, I think there's another way to do it. It would make sense if there is. And you're questioning in that. That's what I love. Also, you guys are going to hear me call you liars a lot this year. Because in math, I feel it's easy to call someone a liar until you prove me wrong. So just like I said that, I was like, no, there's not another way. You're a liar. I don't believe you. And she's like, well, and she showed me another way. That's called proving. In math, we don't want to just accept answers. We don't just go, oh, and why does that happen? Oh, because that's my answer. No, that doesn't work. You have to prove it to me. Give me facts that I cannot argue. Yes?
My dad calls you a liar.
I know, a lot of people do.
All the time.
So, here's what I want you guys to do. Before you look at this, can anyone, real quick, point out in this one that we just broke it up, what was one place I could have broken it up different? Grant? Not sure.
36. You could have broke it up into 6 and 6.
Yeah. What if I would have taken this one and said, hey, I'm going to make it 6 times 6 instead of 3 times 12. So I'm still going to say we had the 3, but then I had 6 times 6, and then I would add 2 times 3, and 2 times 3. There's a prime, 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 prime. Our answer still would have been 2 to the second power and 3 to the third. So we could have done it that way. Where else could we have broken up a different way?
You can also have done 3, 6, and 1, 4, 9.
I'm going to go upwards. We could have said 4 times 9. And then that would have became 2 times 2 and 3 times 3. And we'd still have our 3, 3, 3, 2, 2. I'm getting sloppy now. 2, 2, 2.
You can break the 12 up to 4 and 3.
Good. You know what you guys are doing? You're helping me with the next part we're going to work on. What are these that you're coming up with? You just told me I could have made 36. I could have broke it up as, I can't use 1 and 36, but we'll just write it down anyways. But you said I could have done 3. I'm going to leave a blank. I did 3 and 12. You said 4 and 9. 6 and 6. Is there any other way I could have broke up 36?
You could have done 36, and it would be 2 and 18.
Now, just on this one factor tree, I could have had 1, 2, 3, 4 different ways to break up 36. Do you guys know what we call all these right here? Ooh, I heard it. Part of it. What? I'm going to write this way. I know how to spell, that would help. But there's a second word that goes to it.
Common factor.
Ooh, that would work, but no. Nope. Second word. Factor, what happens when we have 2 of something? I have a blank of shoes, a blank of socks, a blank of gloves. These are factor pairs. When I ask you for factor pairs, I don't want to, if I just say, what are the factors of 36? If I say, what are the factors of 36? You'd say, 1, 2, 3, 4, 6, 9, 12, 18, 36. Those are all factors. Those are all numbers that go into 36. If I say, what are the factor pairs, it means which 2 go together. Like, when I go to the store, I buy a pair of shoes. I don't buy this one, and then I'm like, hey, look, I'm going to get this one too. Actually, that's the left one, so it wouldn't really work. But I don't take this one and this one, because are these a pair that go together? No, they're both shoes. So they make sense. Just like if I said, what are the factors of 36? And you could say 1, 2, 3, 4, 6, 9, 12, 18, 36. If I say, what are shoes? You could be like, this one and this one. Okay. So, these would be shoes. They belong to it. But if I go to the store and say, hey, I have to buy a pair of shoes, the guy at the store is going to go, hey, how about this one and this lovely flat to go along with it? So, when we ask about factor pairs, you have to say, okay, 1, well, what goes with 1 to give me 36? 1 and 36 are my pairs. 2, what goes with 2? 18. Now I can put my shoe on because the room is starting to stink. Okay? So here's what we're going to do. Close your notebooks, your workbooks, and get out your notes. I actually am anticipating your group kind of rolling with this pretty quick because you guys have amazing discussions. This is the great thing. When you guys have great discussions in math, you kind of answer a lot of questions. And you will get more time for your homework. All right. And the homework becomes easy. Okay. 1.3. Make sure we write our name on here. Not my name. I know you all want to be like me. Don't lie. Alright. You put your name on this. We're second block for Purple Day. 8:30. Remember, where are we going to put these notes when we're done? In our avid binder at the back. Okay. So, very first thing that we have to discuss. Hey, look. Huh, a factor pair. Ain't that crazy? What is a factor pair? Who thinks they can come up with discussing what is a factor pair then? How can we define a factor pair? Yes, my shoe partner.
Two factors that go together to make a bigger number.
I'll take it. If you want to change it, your wording, that's fine, but shit. Choking on. I'm choking here. So, she's right. A factor pair are two factors that give us a new product. So the only thing I would change is that maybe we would use more math vocabulary in it. Two factors that make a product. Just for fun, before we get into our lesson, can anyone give me a factor pair for 12? You can even have the infinity ball. Oh, we just killed a point. Okay. What's a factor pair of 12? Okay. 6 times 2 or 2 times 6. So I'm just going to write down 2 and 6.
1 times 12.
Huh?
1 times.
Oh, I thought you said 12 times 12. I was like, no! Oh, Gio with the steal.
3 times 4.
Now notice, since I asked for the pair, all I'm writing down is these numbers. Now, question. I heard you say 3 times 4. So I wrote down 3, 4. Do I have to write down 4 times 3?
No.
No. Because it's going to be worth the same. However, it could change my arrangement in my picture. Okay? We're going to see that right here. It says, finding factor pairs. The brass section of a marching band has 30 members. Whenever I read story problems, I highlight what's important. I don't care if it's the band. The band director arranges the brass section in rows. Each row has the same number of members. So same number of members. How many possible arrangements are there? Okay, so now they want to know how many arrangements. So the first thing I have to do is I have to find all the factor pairs. Now, to do so, I'm mainly listing what are my factor pairs of 30. Well, we came up with 1 and 30. However, I have to count this one twice. Why do I have to count this twice? Oh, what's the other question? What will you answer?
I was going to say, you can do 6 times 5.
Ooh, good. We're going to get to there. But why do I have to count 1 and 30 as 2? Why do I have to count that as 2 arrangements? Yeah. Now, even though it gives me the same thing and it's the same factor pair, if he asked me for arrangement, couldn't I do 30 people in one row? Or I could put one person in a row but have 30 rows. That's going to be drawn up different. If I had you guys all sit in one row in my classroom, we'd go left or right. Or if I put you in 20 rows, we'd have a horizontal line. Okay? So, it's important. Now, instead, I'm going to pick on you because you said 5 times 6. Is he right? Is that a factor pair? Okay. So if you said 5 times 6, okay, now I'm going to think, does 7 go into 30? 12? 17? 13? Oh my gosh, do I have to check all 30 numbers? There's a shortcut. And here's what it is. hope this isn't something new to you because I know my students in elementary, I always did this with them when we worked with factors. So I'm going to write 30. I'm going to make the upside down rainbow. Now, if you want to make it just a rainbow, that's okay. You always start with 1 in the number itself. So 1 times 30, and here's my upside down rainbow. I draw a line. Those lines that touch each other means those are factor pairs. 1 times 30, or 30 times 1. Now, what comes after the number 1? 1, 2. So I'm going to check to see if the number 2 goes into 30. Does 2 go into 30? Yeah. And this is really where if you're not strong with your math facts, don't worry about it. Use your calculator. 30 divided by 2. Oh, it goes in there 15 times. So 2's on the left side. 15 goes to the far right. 2 times 15. Okay, I'm still not real good with my math facts. So after the number 2 comes what? 3. So 30 divided by 3 equals, okay, so 3 goes in. 3, 10. Whoop. Okay. After 3 comes the number 4. So 30 divided by 4 equals, 7.5. Do I put that?
No.
Or are we using whole numbers? Okay, after the number 4 comes 30 divided by 5, 6. So 5, 6. Whoop. After the number 5 comes the number, I already did 6. So, no. I'm done. I only had to check 5 numbers. The reason is, when you go in numerical order, if I get to a number I've already checked because of its factor pair, I'm done. There are no more numbers I have to check. When we did the number 100 in elementary, we had to list all the factors of 100, and the kids were like, oh my gosh! We checked 10 numbers. That's it. Because if you don't do it this way, they're like, it's 33. Okay, what about, 33 was close. What about 34? What about 35? And they keep going up. If we go in numerical order, you don't have to do as many. Because we end up finding the middle. Now, if the person asked me, how many arrangements could I have? My factor pairs here, I still have to write those down. But after I do this work to help me, where did my upside down rainbow go? My factor pairs are 1 and 30, 2 and 15, 3 and 10, 5 and 6. And if I'm looking for arrangements, I could do the opposites. 30 and 1, 15 and 2, 10 and 3, and 6 and 5. How many different arrangements could we make? 8. You would just count up all the factor pairs. The easiest way, I think, is count your factor pairs and times it by 2. Just to do the opposite way. Okay? So, let's use that idea. All they did was take the factor pairs and apply it for here. I want you to do the try. The instructions say list the factor pairs. So, did I have to list one? When I did 130, did I also have to list 30 and 1? No, you don't have to. If you list 1 and 30, that's going to count as both. So, go ahead. Can you find the factor pairs of 18? You may work with your table group if need be. Alright. What were the factors of 18? Who can give me the first pair? Ainsley? 1 and 18. Jeez, I'm having trouble writing today. 1 and 18. Don't laugh at me. You hurt my feelings. I'm a teacher. I still got feelings. Kiori. 2 and 9. I'm gonna switch. I'm gonna do this. I'm gonna switch colors so it's easier for you guys to see. So we said 1, 18, 2 to 9,
3 and 6.
3 to 6. And that's all.
4 to 4.5.
If we went to decimal, we're only working with whole numbers now. Alright. What about 51? Let's go to number 3. 51. Okay, we got 1 and 51. Grant?
17.
17 times 3. I know I did. Okay, what I'm doing is I'm showing you how you can be getting help because this one's kind of tricky, right? And so people are still, I don't know if they're real comfortable with it. So, if I'm looking for 54, or what am I, 51?
51.
So I did 51 divided by 2. Does not work. So I know 2 is not a factor. 51 divided by 3. There's my 17. So 3 and 17 are factors. 51 divided by 4. No. 51 divided by 5. No. 51 divided by 6. 8.5. 51 divided by 7. 7. 51. Now pay attention to this one. There's something important about this. Divided by 8, right? What's the answer then? What's important about noticing about that number though? I divided by 8 and my answer was a 6 point something. Why is that important to notice? Think about the values of the 8 and the 6.375.
Well, now we know that 51 divided by 8 is.
And we know it doesn't go in there, but something else. I'm done. How do I know I'm done? I don't have to check any more numbers. Why do I know I don't have to check any more?
You can't divide that number.
Okay, but why? How do I know I don't have to check 9, 10, 11, 12, 13?
Because when we checked 6, we got an 8. So maybe then when we checked it by 8, we got a 6. Yeah, so it's gonna.
The biggest way is, notice when I'm going to back up a few. I'm going to divide by a 4. Okay, 4. And I got a 12 something. Is 12 more than 4?
Yeah.
And divide by 5. Is 10 more than 5?
Yeah.
So that's on that other side of the rainbow still. I divide by 6. Oops. 4 times by 6. 6 is 8.5 more than 6. So it's still on that other side of that upside down rainbow. I divide by 7. 7.2. Is that still on the opposite side? And I divide by 8. I got 6. Was that on the other side? No, they crossed each other. If I divide by a number and I get something smaller, well then I know I'm done. I've checked them all. Because otherwise it's going to not make my little upside down rainbow match. Alright. Now, we've already identified prime and composite numbers. Okay? We've already done this part. Prime numbers, 1 in itself. Composite number, more than 2 factors. Here's where we are going to work on the prime factorization. Okay, this part should go pretty quick for us. I'm going to show my explanation quick. I think you guys have done well. We'll practice it together. So, they looked at 48, and I said 2 times 24. 2 was prime. You circle it. 24 becomes 2 times 12. 2 is prime. 12 becomes 4 times 3. 3 is prime. And then 4 is 2 times 2, and it's prime. Once I circle and I'm down to only prime numbers, I'm done. Then, I don't like how they did this part. you need to go ahead. It says find a factor pair and draw branches. Circle the prime factors as you find them. Find the factors until each branch ends in a prime. Once I have this, I then will write this out in order. So my smallest number is 2, and I had 1, 2, 3, 4 of them. 2 times 2 times 2 times 2. I had 1, 3, so times 3. On your homework tonight, you will put in the answer 2 times 2 times 2 times 2 times 3. Now, can you put in 2 to the 4th times 3? I think your homework will accept it. When we start our homework, we'll try it. Okay? So here's what I want you to do. Can you guys find, let's do number 5 and 7. Okay, I'm going to pause, work on that, check it with the neighbors. Remember, are there multiple ways to find your answer? Yeah. We just have to check our final answer. Alright, let's come together. Let's see what we got. Did anyone break up to 20? Alright, Elizabeth, what did you break 20 up into? 5. I like to make the multiplication sign in the middle, just so I keep it straight. 5 times 4 is either number or prime number. Awesome. 5 is my prime. Okay, what about 4? Okay, so 4 is a composite number. I can break it up still. To 2 times 2. Is either one of those prime? Oh. So what is my answer? Well, we want to write our smaller number first, okay? And I believe if you write 5 times 2 times 2, it's going to give you credit. Or if you did 5 times 2 squared, you get credit. Now, I'm not going to write other people's examples up, but if you solve it another way, it's okay, but did you still get 2 squared times 5?
Yes.
Okay, the way you can always double check yourself when you're done. Very, very easy. I'm going to show it real fast. Double check yourself. Do your prime factorization. 2 times 2 times 5 equals 20. Whew. I'm there. All right, let's go to 90. What do you got?
I broke it up into 3 and 30.
3 times 30. Either one of those numbers prime?
3.
3 is prime. Oh, I didn't switch colors on me. Which means 30 is composite. What would you break 30 into?
I broke it up into 10 and 3. And
3 is prime, so 10 is composite. Both are prime. So what would be your answer?
2 times 4, 3 to the 3rd power times 2 times 5.
3 to which power?
2 term.
Why third?
Oh, no. 3 to the 2nd power.
Good. Or I could say 3 times 3 times 5. Or 2 times 3 squared times 5. Alright, there's one last part I want to work with you before your homework. Alright, I don't like this part as much, but we have to go over it. So please bear with me on this. These are more examples. I don't know why this got mixed up. Okay, using a prime factorization. So now what they're asking you to do is you're going to use prime factorization, the factor tree, and we want to find out which one has the greatest perfect square. You guys remember what a perfect square was? We did that in lesson 1.
Any number times itself.
Good. It's the product of any two numbers times themselves. So like 4 is a perfect square because 2 times 2 is 4. You have to have two numbers times themselves, and whatever they equal is a perfect square. So they want to know what's the greatest perfect square of 1,575. Now, do I just go, okay, I know 4 is a perfect square. Does 4 go into that? Okay, I know 9 is. Does 9? Does 16? Does 25? Does 36? Like, how do I find that? The way we find it is using factorization. Okay? So here's how they did this. They took this giant number and we first just did a factor tree. They did 25 and 63. Ooh, 25 is a prime. Or not prime, a perfect square. They did 25 breaks into 5 times 5. Those are prime. 63 becomes 7, which is prime, and 9. 9 becomes 3 times 3. And they get to this. Calm down, Turbo.
Oh yeah, they're doing.
So, we get this. All they've done here, guys, is what you just did. Nothing different, just a big number, right? Now, you can read how they do this if you want, or you can do it the way I'm going to do it. I think my way works easier. First, with these prime numbers, are there any two numbers that match? What two numbers? What are their two numbers up? Ainsley? Okay, there's 2 3s. And there are 2 5s. Okay? I don't care about the 7 right now. What I'm going to do is I'm going to say, what is 3 times 3 times 5 times 5? If I want to show my work, this is a perfect square making 9. 5 times 5 is 25. And then 9 times 25 is 225. If you use your calculator, it would help you. I could have just done 3 times 3 times 5 times 5 equals 225. 225 is our perfect square. Because, I'm going to show you this. You don't have to explain this part, but I'm just going to prove this to you. It's because it is what 15 times 15 is. Do you know how I know it was 15 times 15? Yeah. Because even though I had 2 pairs here, I had 2 3s and 2 5s, I could have said I had a 3 times a 5 and a 3 times a 5. 3 times 5 is, so I did 15 times 15, gave me my perfect square. Okay? I'm going to pretty much stop there for the day. When they talked about greatest perfect square, do the factor tree like normal, identify pairs. So if I look back, let's go up to one we already did. Let's look at this one. Number 7, 90. If I look for its greatest perfect square, here's my answer. 2 times 3 times 3 times 5. Was anything repeated twice? What was repeated twice? Is there 2 2s? 3. So 3 times 3 is 90's greatest perfect square is 9. How about 20? I have 2 2s. 2 times 2 is? So 4 is its greatest perfect square. On 48, did we have anything repeated? I had 2 2s, 2 2s. 2 times 2 is? And then we have the other 2 times 2 is 4. So 4 times 4 is? Its greatest perfect square is 16. Yeah? Alright. We're going to stop there. When you do your homework, where do your notes go?
And your Avid binder behind your syllabus.
Good. Alright. you're going to put your name, date, lesson, and 2P. Make sure you show your work, because when I collect them, I already wrote down you guys' grades for lesson 2. But now I have to go look at your paper and see, did you turn work in? If you didn't turn work in, I'm taking one of your points away. Okay, so if you still have your work for lesson 2, please turn it in the tray. You have 15 minutes to be working on your homework. Please get started so I can help you. What do we do with our workbooks?
Put them back in the grade.
Put them in.